The launch is a spectacular start of a satellite's long and hopefully productive life, but too little attention is paid to its end.
Currently, there are around 2,000 active satellites and 3,000 dead satellites around Earth's orbit. Dead satellites can remain in low Earth orbit for 5 years to a century. Companies such as Amazon and SpaceX are planning to launch thousands more satellites into space.
NASA predicts that 1,400 new satellites will launch in the next 8 years. The defunct satellite poses a major collision hazard to these actively operating satellites around Earth. So why is eliminating the small chance of colliding space junk worth it? According to the Kessler effect, one collision can cascade and spark further collisions. It would become a domino effect that can potentially damage a lot of operational satellites. So deorbiting satellites to the graveyard orbit or the Earth's atmosphere is essential in ensuring future space activities and for future generations. Space activity is evolving at an increasing rate with no regard to preserving a safe space for future satellites.
Our solution is to equip a cold gas thruster with every future satellite in order to help them fall into the atmosphere sooner once the satellites become defunct. By taking this precautionary measure, we can ensure the future innovations and space evolution can be done without obstacles, literally. Our object is to deorbit future satellites using an dependently operating manned deorbit model to be installed on the satellite prior to its launch from Earth's surface and to be maneuvered following the end of satellite's operational life into an orbit that allows for passive re-entry and burnup in Earth's upper atmosphere.
Engineers have perfected a design that is low in weight and efficient in size. As you can see in the picture, we utilize a hexagonal structure that can decrease the weight while maintaining structural integrity, making it the most cost-efficient model on the market. Low weight and size are important to keeping costs reasonable, especially when a single kilogram can cost upwards of $30,000. Today, satellite operators sacrifice propellant and therefore the satellite's life and potential revenues. Our design allows satellites to maximize its propellant and fully utilize our system to deorbit.
And the best fuel efficiency is also achieved by adopting our deorbiting strategy. The picture shows the low Earth orbit, and the intended targets for this project are small satellites. This comprises a large fraction of population of satellites planned for launch into Earth's orbit in the near future. And the project's physical design is intended to be adaptable to the diversity of small satellite structures as possible. Finally, given the chosen method of propulsion, the project is intended for satellites operating in low Earth orbit. Thank you.
Thank you for your time.